Good afternoon, morning, everyone, depending on the time zone you're currently in. We took a different approach to a webinar series that we're going to put into place over the next several months that hopes to explain more of the entire workflow of producing a digital factory and what the purposes are and the why behind it. This is part one, and part one is going to focus on capturing existing conditions in your current facilities around your country or around the world, wherever they exist. Everything that's discussed in this webinar is all around capturing existing conditions of factories or facilities and can be applied to that type of environment. If you go to the next slide, please, Ellen. Yeah, so the agenda today is first we're going to talk about just what our intention is of the overall digital factory series. Then we're going to talk about digital twins. We're going to talk about different technologies and use cases for capturing reality, how to do it, the why, and the different methods and the accuracies. And then we're going to talk about scanning inward and planning for layout and design of new equipment or new factory lines going into a facility, and then take any questions that anybody might have. Next slide. So just a little bit about IMAGINiT. If you're not familiar with us, what we're doing here is leveraging a lot of our partners inside this technology session. So you can see RAND Worldwide is IMAGINiT Technologies is part of us. We also have Epic Games like Autodesk and Aptora. We're almost going to be touching on almost every one of these industry partners along these web series of sessions. This session primarily is IMAGINiT Technologies with the Autodesk portfolio and Leica and also just Autodesk technology in general. Whether you're using Revit, Inventor, AutoCAD, Recap, it really doesn't make a difference at the end of the day. It's data, and what we're going to do is show you how to use and consume this data in the various platforms that we all support. Go to the next slide. We have a very large company at IMAGINiT, and through our partners with sister companies at IMAGINiT, so we can do lots of different services for our customers, and we do these services every day. We have 150 technical engineers that are out developing standards for companies, helping them implement CAD and BIM standards, helping them capture standards for reality capture services, to CDFD simulations and FEA simulations, and our software development services, of course, as well. Our goal is to put all of these things or all these services together and be able to service our customers as best as possible. Next slide, please. And just one more. So the Digital Factory Series. So the Digital Factory Series is a concept that we came up with a couple months ago, and we've done webinars for years, but we've never really tried to put a series together that connects the dots between all the different technologies that we use, and that's the purpose of this. And if anybody has any feedback as to other things they would like to see, please type it into the Q&A on the GoToWebinar, and we can maybe address that as well. But the use cases that we came up with to try to focus on and to demonstrate to you all and explain to you all is really a 5-part series. And part one is going to be this one that we're attending today, which is the options for capturing your existing conditions. Part two is going to be, okay, now we have that existing conditions captured. Now we are doing the equipment swap out in our facility. We're doing a line change. We're doing something. And we want to take a look at how do we leverage that point cloud or that reality capture data and look at how we design the new facility or the changes in the facility and different layout options. Third section, part three, what we're going to do is build upon that layout and talk about more about layout validation, so simulation of and coordination of the models. So think about things like packages moving around a facility or people moving around a facility or equipment moving, robots moving, whatever it might be. we need to understand that what our design intent is can be validated through a simulation and understanding how product might flow through a factory floor. The fourth part, we're going to talk about, okay, now we designed it, we validated it, now it's time to build it. Okay, so let's go out and build it. What's the tools of the trade for the pre-construction side? What do we manage? What do we need to manage on the construction side? And how are we going to close out that project? So, you know, not every owner cares about these things. You might have subs that do some of these parts, but everybody's got to work together and collaborate to a certain extent. So, you know, what the owner's role is in the pre-construction and construction management, and it might be a small project of just installing with a piece of equipment with a trade coordinator, but we generally manage those things. And part 5 is going to be around maintaining the facility. How do we keep this reality capture model up to date? How do we leverage this data in our facility for operations, and then potentially down the road for additional remodels or different equipment shop swap out things. In the next slide, I talk about just about all the different types of use cases. We decided on those 5, but there's other use cases that you could consider with reality capture and digital twins when it comes to what am I going to use it for? And this is really important to understand so that you know what level of data you need to collect and the accuracy of the data that you need to collect. So, you know, some just example use cases is, you know, performance monitoring is, you know, monitoring equipment, monitoring machines, you know, further wear and tear and understanding, you know, what the performance matrix are on that machine. Predictive maintenance type things where we can say, okay, you know, this machine's been running for 10,000 hours. We need to retorque certain bolts or nuts or whatever the case may be. Simulation and analysis. So that's, you know, one of our webinar series parts is around the simulation of a factory and understanding how packages are going to move through an area and analyze, is this the best design or should I look at design alternatives? Remote monitoring. So, you know, think about, you know, video cameras and cameras around facilities of being able to watch things, but also sensors on devices and understanding what is happening at the equipment lines. Collaboration and communication. I think this is one of the more important ones is, you know, collaboration amongst all the parties that are involved in this project and installing this thing. How can we use that in maybe in virtual reality and a mixed reality type environment of taking these models and having somebody put on a pair of glasses and be able to walk through the facility, understand what it's going to look like, understand how difficult it is going to be to remove a piece of equipment from an area, or how easy it may be to remove a piece of equipment from an area. Training and simulation. So, you know, you could use this in theory for an XR type environment of, hey, we need to train users on equipment, or we need to train users on how to properly remove that equipment from a cell or something. So with that, I'm going to turn it over to Alan DeLuce, and Alan is going to start talking about the different ways that you can capture reality. Oh, one last thing is the digital twin. So all this goes into the digital twin bucket at the end of the day is how do we capture the real world information? What information do we capture and what information do we model? And then how do we connect that data to any other systems that we may need down the road? That's the overall intention of this webinar series, is to show you how to capture data, how to use the data, and then ultimately how to maintain that data so that you have a real world digital twin of a line or a machine or a building. Okay, Alan, awesome. I'll turn it over to you.
Good deal. All right. So there's a number of things that'll come up throughout this series, and terminologies that you may or may not have come across before, because of, you know, like Scott is talking about, we're going to be talking to everyone at some point. What we're talking about in this series is going to touch on every person who is involved in a building throughout the entire life cycle, from schematic through construction documents, through handover to the owner and operations, and and everything, right? And so for today, some of the focus is really going to be today on the kind of the greenfield and brownfield, but today particularly on a brownfield concept, where greenfield, hey, this is a new site, it's unblemished, it's a lot of time it's agricultural, old land, and then we're going to go and build on it. But for brownfield, it could be an often underutilized building or whatever it may be, but ultimately could just be our existing facility, the context of an existing facility where we're going to go and upfit or basically retrofit our existing building with some new facility. And so in essence, just renovation. And that's what we're going to be talking about today with capturing existing conditions. So reality capture, a couple of the things we want to focus on today, the concepts and formats, kind of what kind of reality capture do we have available to us today, what kind of the formats, that type of thing. As far as how do we execute in reality capture, what are the tools that we have in front of us that we can go and actually do the capture itself? Do we have and how do those tools apply to the various scenarios and the formats, or is it needing to use a drone for some imagery of a site? Is it needing to do to get very, very particular with some metrology and utilizing a CMM? It just depends on what your application is. We'll talk about some of the tools that come up throughout the various reality capture context, and also kind of what are we going to do it for, and why are we going to use it, and then maybe how might we utilize it downstream in the future. So a couple of things I'm not going to go into depths on too much of it because we want to stay a little bit high level, but ultimately, what are the two formats we want to focus on? And that's really LIDAR and photogrammetry. And so LIDAR being, light detection and ranging being the acronym. And LIDAR is what we perhaps have all seen or heard of in the past. You're going to see a laser scanner. If you've ever been driving along the highway and you look over and, for a long, long time, we've seen LIDAR be utilized in long-range survey and scanning from a civil perspective. So you look over there, they see the person on the tripod. They're scanning, 300 meters away. There's some really high-powered lasers that they use for that type of application. And so that's an application we've known for a long, long time. But then there's newer applications that we see in every day that's a lot more close to home even. So photogrammetry, the root of that word being with, I'm going to butcher it, so I'm not even going to go into it, but there's the root of the word being just basically with photos and being able to take measurements from photos. So as you can see here in these second couple pictures, you see a couple cameras taking different perspectives of the same content. Those we're able to take with the photogrammetry technology, to be able to take multiple perspectives and stitch them together to create the whole, right? And create basically a mesh or a point cloud mesh of our object. And as you can imagine, think of the camera in the second picture and the cost of that camera versus the laser scanner in the LIDAR scanner. You can just imagine the cost of those two tools and how might one be more applicable to maybe the scale of the scope of what you need to capture versus the second one that might be a little bit not as big of a scope that you need to capture. That's how we're going to move into the next that's how we move into the thought process of determining how do we determine what is going to be applicable for my use case. So let's take a look at some of the a number of the additional tools that we have out there in the market today and kind of where they fit. So again, going back to old school, we've all seen these terrestrial laser scanners. At some point, you may or may not have ever even noticed that you saw it. But the terrestrial laser scanners, kind of you see the it's sitting on a tripod and it's scanning, whether it be outside or inside a building. You can see there's newer versions of those scanners that have become more compact. They've become much more lightweight and just much more conducive to be able to maybe travel with or whatever, and just easier to move around, things like that. So that as the technology grows and expands, we're going to be able to use it in so many new ways. But ultimately, it gets, oftentimes it just gets a lot smaller, as we can see here. So maybe we need to go and think about how are we going to apply this for large scale capture. Say I need to go and fly, a 10-acre plot. Well, how would you go do that? How would you go capture that site? Maybe there's some berms on the back corner. How would you go capture that site so that I know how am I going to position my new facility on a site? Well, you might want to use a drone. And that technology is available to us as well to do with both photogrammetry and taking photos, but then also with laser scanning and LIDAR. So there, that technology exists in both locations. And then we could talk about 3D and basically determining how do we want to get into the market. I know that I want to be able to capture my space because I need to know what my space is, and I want to be able to distribute that space and give it to all of my sub-consultants or the people that are going to work in my building, and I want to distribute access to my building. Well, you have to determine why and how you would do that. Well, maybe you can do it in a more cost-effective manner with a 3D camera, and you can do it pretty quickly with a 3D camera. Well, you could also even do that. There's new tools and there's cloud-based platforms that allow you to do that with just with 360 cameras. So you can see there kind of just the maybe you're a construction foreman and you're walking along through the building and you have it on your hard hat as a construction project's going along. You slap one of those 360 cameras on top of your hard hat, and you're able to go and take that downstream to use it in a quote unquote reality capture context to be able to go back and do measurements from things and all that kind of stuff. So you can imagine the speed and the scope. Those are the things that are going to drive us to a decision on which technology do we choose. And then kind of down at the bottom, a SLAM device. That product is something that you can walk around with. It's called simultaneous localization and mapping. So SLAM is just basically a typical static laser scan, but you're walking around. You're actually able to go and take photos as you walk, and you're walking a location. So maybe you need to capture a 200,000 square foot facility, and there's maybe multiple floors. You're not necessarily worried about getting down to the super granular detail, but you have a lot of space you got to capture, and you're going to go do this on the next. You're going to purchase 10 buildings over on a campus or something, and you're going to go and retrofit those. Well, maybe you need to capture a lot of space. That would be, for instance, a tool you would use in that context. And then something I think that we all may or may not even be aware of that is very cool, and I would actually suggest that as we leave today, if you want to go check it out, I actually downloaded it yesterday, and I've used it in the past on my own device. But the new smartphones have LIDAR scanners, and you can see that if you look at the back of your phone, there's a little one of the little circles on there is going to be the LIDAR scanner on your phone. Go download an app and then go check it out. Go do a quick little scan. You'll be amazed at the level of detail and just the capture you can get out of a 3D, just out of your camera, right? The phone that you have right in your pocket. And ultimately, to say there's use cases and there's tools of the trade here, and they go from the top to the bottom. We've all got them in our pocket, most likely. which is something that's wild. All right, so kind of just to focus on some of the things we just talked about, we have to to determine what should we use, when, and why. Well, we have to determine our project needs and what is there a requirement. Well, say that this is in your facility, and as was spoken of earlier, hey, we want to go and do a change out of a line in our of equipment in our facility. We need to make sure that there's going to be enough egress and there's enough space to actually get the new equipment into the space, so I can determine how much I might have to reorganize my potential, one of my factory lines or something like that, so that I can actually facilitate this new design, that type of thing. We need to go and simulate that. Well, how are you going to simulate that if you don't have good documentation of your facility? Well, that's where maybe a laser scan would give you that access to the existing conditions of your facility, so that you can now go bring that into your design environment to be able to go do that type of simulation, right? Well, that's what we have to think about. What are the needs? Well, I have to determine, am I, circling back to that last slide, hey, am I capturing that site for a greenfield, this new facility? Well, okay, I'll go do that with a drone. I'll capture thousands and thousands and thousands of square feet. Or maybe it's not necessarily that much square footage that's like the site, but I do need to actually capture the interior of the building, and I need to capture my entire building. So say that you're, as an owner of a facility, you're going to go move your factory, or you're expanding. Maybe you're just going to go and retrofit an existing area of your building. You're going to move what was maybe laboratory over into office space or vice versa. You need to be able to go and retrofit that. How do you go and best capture that environment so you don't have to go get your, you get your tape out and start doing measurements? We all know the fun that is. So which tool at what time is going to be applicable for that application? The drone, or maybe a terrestrial scanner that's going to be super high level of detail. Or even, again, like I said earlier, hey, maybe we just need to go and get a really quick capture that says, okay, I need to get into this space and get out. Say that there's a requirement. Say this space has has some kind of clean room situation where you can't have you have to shut it down, and you have to have very limited access to a location, but you only have a certain amount of time for that capture. Well, that's where we could go and have one of those more handheld devices, SLAM device, or maybe even something else that would facilitate a quicker capture. That's something that's going to be utilized in that application. Ultimately, one of the main things that we really need to consider is the accuracy of the data. So what is this data going to be used for? Is this data going to be used downstream for handing over to my design team so they can start, they aren't starting from scratch? Is it going to be something where I need to make sure that I'm just going to have enough space because I'm, again, maybe you did acquire a new facility and now you've got to ensure that you have this much room for these 5 lines that you're going to deploy. Do you have that much? Do you have enough space? That's how we can go and assess, say that you're in the market for this space. That's how we could go and actually capture that and do a little bit of quick and dirty simulation of a space in the digital realm, so that we're not having to go and spend a bunch of time on paper or in with other methods, just trying to figure it out. So those are, these are some of the things we have to consider. Some things that when you get, we won't go too deep into detail here, but we do want to kind of get an idea and say, hey, once we do get to the point where we understand it's going to be way more cost effective for us to actually have a laser scan of our space, and maybe not even just one, of course. Maybe you're going to be able to take numerous scans over the life cycle of your building. That's where we have to to determine, hey, this is going to be utilized for me downstream. I want to make sure that I'm doing progress scans, et cetera, et cetera. Well, these are some of the things. Once you get to the stage of understanding you do need laser scanning and point clouds or photogrammetry models, digital, and essentially the reality capture of the digital twin aspect of your digital model, your digital factory. These are some of the granular details that you want to understand. Okay, points per, such as points per second. Well, you can imagine some of the more cost-effective solutions, they're not going to capture as much data per second, right? Well, do I need to capture from here to the other side of the factory? Do I need to capture, 300 yards down the road? If you do, then that requires a certain type of scanner for sure. But if you just need to capture, maybe you're going to do, you have on for fiscal year 2024, you have to capture 3 or 4 areas that you're going to change out, but they're not huge areas. Well, maybe you don't have to go with the long range scanner. You could go with something a little bit smaller, and you could just have that to scan that smaller area to so you don't have to have that same range. The other things that are super important is data transfer. How am I going to get information from here off of this device onto the cloud and distribute it to my team, right? So there's different things that we have to consider when we're getting into the stages of evaluating a solution that we really need to take into account. I have calls with people all the time that are working in maybe different environments. So say you're going to do maybe you're in cold storage or things like that. It's something that I've actually come across in my career. Not even really considering taking into consideration, wow, I really need to make sure that I can actually execute this because it's going to be in a cold storage facility. So these are things that we also have to consider when we're talking about a capture solution. All right. So some of the applications that we are typically, these are things that are just kind of low-hanging fruit. There's, this is the stuff that we already are doing, and as this technology grows and expands, you'll come up with your own ideas as to how can I leverage this in my daily work. But right now, as I spoke of earlier, hey, we want to make sure that we're not having to reinvent the wheel. Again, if it's a new facility, probably not a big deal. You're going to be designing from the ground up. But say that it is this brownfield or it's a retrofit to my existing building. I want to make sure that I have that my drawings, that my content that I'm handing over to my architects and engineers, ultimately contractors, is legit, because we don't want them to have to go out to the field and or be designing from bad information. We all know garbage in, garbage out. If you start a project, a design from, say, existing documentation, how often have we all, worked on a building and tried to, moving into maybe a new facility and there's no good documentation of that? Well, what is the most efficient way to get that documentation up to date? That's super important, and that's where reality capture can come into play to actually get us the data set that we can then get those documents to be able to essentially extract our building documentation from, to get us down the road faster so that we're not having to reinvent the wheel every time, number one, and number two, we're not starting from bad data. So as far as scan to BIM, and as far as that exists, it's actually a part of the AEC industry. It's a kind of a sub level of the AEC industry, where the scan to BIM, meaning taking a laser scan and turning it into a BIM, that is kind of something you see there on the bottom right, this image of, you can see kind of the specular dots, that's our scan. And then from that, we're able to take that and turn it into a building information model. That building information model, that's what the archs and engineers and contractors are going to be using, of course, first and foremost, to design your building, but then ultimately to construct the building, right? So in this day and age, and for those of you that are on the call, you're clearly interested in it and understanding of it. A more robust 3D data set has become really ubiquitous in the industry. 2D is never going away. It's got its application, but we really need this 3D capture and the 3D model to be able to compete in today's world. And so that's where we can start from scratch. If we have bad data, we do a scan, bring it up into BIM, and then we're able to leverage it for these downstream activities, such as clash detection. It's one of the biggest things in industry for sure. Whether it be in the design phase, hey, my company or my consultants, they need to work in design and making sure that they're delivering good information downstream to construction. Well, those construction folks, they're going to leverage that information to have a better starting point, ask fewer questions, things like that. So just a cleaner process, a smoother process. That's where this reality capture is going to come into play. As we'll touch on in later pieces of this series as well. So again, maybe you are changing out that line, but you're not sure, you're not sure what your production levels need to be at. Well, you can do, once you have that existing as-built condition, you can go and kind of do some iterations and simulate what one version of a line simulation would look like versus another, and do iterations and things like that that'll allow you to make better decisions downstream, better real-time decisions that will affect your productivity downstream. And again, a couple of things that actually we want to make sure that again is that at the end of the project, we want to make sure that we actually captured what was completed. That's the install verification type of concept. Well, hey, we saw, this is what we were given from our design team. This is what they actually did. And spatial simulation, basically just being able to say, hey, I captured this. How could we best make changes to this space and simulate what would eventually happen in a new design? A couple things, and then I will hand it off. So, what can we get out of this type of this scan data? Well, a couple things. If you have the tools in your tool belt, you can go and actually do progress scans and understand that, hey, things are coming along as I see fit, and I'm able to take that data, ensure that what was designed and what we're being told is being done, and you've got that moment in time, you've captured it. Kind of just having read up a lot on it and understanding it. That's one of the reasons why it's in law enforcement and in our legal system, they've actually adopted laser scanning, because they need to be able to go and capture something at a freeze frame in time and be able to take that and go and, whatever you want to call it, investigate it on the back end. Well, if they go scan a scene of a crash or whatever it is, they're able to go and actually be able to utilize that downstream to, hey, I didn't take a picture of that one thing. Well, when it's scanned, it's all there. That installation verification, think about it, if you go put up drywall, or if you go put up barriers in your facility, or whatever the case is, what did you do? What's behind that? What's behind that wall? Well, if you have a laser scan of that you were, doing kind of a progress tracking context, hey, now I know it's there, because you can go back in time and see what was there before those walls were put up. And again, lastly, once you get that scan, get it on the cloud, I can now loop in my stakeholders so that, hey, I can tell someone who's maybe in a different country, one of my project partners, or say you have facilities globally, you're able to go and take this as-built data set that can now be consumed onto the cloud, for instance, and then distributed to your other project team members. So this is just scratching the surface of the value proposition and some of the tools and the concepts of laser scanning and reality capture. And I'll pass it over to Mark.
Thank you, Alan. So what we're going to take a look at now is a little bit of a precursor to our next webcast we're going to have about designing and layout work. So we're going to talk about scanning inward here primarily. Now, if we've captured a large area with any number of the different types of scanning methods that Alan talked about, we'd like to maybe parse that down a little bit. You might want to remove certain things from it, right? Because if there's one thing that's consistent about factory layouts is that it's changing. Things get moved around. Who put that pallet there? Why is that garbage can there? Why is that toolbox over there? So once you have your scan, one thing you want to do is scrub out the things you really don't care about, right? You don't care about maybe some of those consumable things like pallets and garbage cans and things of that nature. You care more about the equipment. You care about transportation mechanisms like a forklift, or robots and conveyors, or machinery and CNC machines, or perhaps entire work cells. So making the scan data digestible to be utilized through design applications and collaboration tools is very important. Be able to move things around effectively. Now, what's great about scanning these particular items is that you don't have to go out and search for a model that isn't even close to what you have, but it was called the same thing perhaps. Or having to go to a parametric software and actually design it from the ground up and actually model something and call that your asset. Being able to use the scan data can be a very quick turnaround to get these things very quickly. Some of the biggest roadblocks for digital twinning and digital factory is the amount of content that needs to be created. Scanning is definitely a shortcut. It's definitely a way to get you there faster, and you can go through and parse out the data, which is important to you. Alan, next slide. Now, once you do get your scan data, as I mentioned, parsing it out and making it more consumable is very important, right? So some of the nuance, some of the minutia here is about cleaning the scan, right? So I have a before and after image of this little generator. It's on wheels, so it does move around the facility quite a bit, right? So we want to clean the scan up so it's easier to say we need to have these over here during this process, right? So we want to clean off the floor. We want to remove those extra points from the scan. We want to do X and Y, Z alignment so it's easier to place and move around and work with. We want the right orientation of that asset. And we will make sure that when we place it in somewhere, we have a good origin point. So these are all things you can do with reality capture software for use in your design layouts. Next slide, Alan. One of the more important things about your scan data, once you've started capturing it and started consuming it into design software, is that you capture file properties, capture metadata. You capture what this thing is, right? This is a Troy-built generator. Well, I shouldn't call it a Generac then, right? I should have the information associated to it so that as we're building up a digital factory, that if we start tagging things as assets, if we start inquiring about them through our different collaboration tools and software, that we're all speaking about the same thing. So you should typically put in to your asset building everything you know or everything you will need to know about this particular asset, right? So having the scan data, great, but the data is king here. The data is going to help proliferate this throughout the entire digital factory. If you want to start creating barcodes for scanning or having sensors that report on things, having the right data about what something is crucial. As you approach a digital factory and you start creating assets like this, it's important to have an asset development checklist, something that says, by pain of death, we have to fill out these things in order to move forward. We have a validation of what each one of our assets are. So we can track them, we can understand them, and we can consume them properly throughout a digital factory. So again, this is sort of a precursor for our next session, which will focus primarily on layout design and working with those sort of aspects. Alan, next slide. I'm going to turn this back over to Scott.
Gotta find my unmute button. Thanks, Mark and Alan. They covered a lot of great information on capturing existing conditions from the building standpoint and also from the asset level. In this session, hopefully learned a little bit about different options for capturing that technology. Did get a couple comments about other things that people would like to see in future webinars. So obviously, thank you for that feedback. If anybody else has any questions, feel free to type them in the window. But the next session we got scheduled for January 25th, and in that session, we're going to be focused on taking, once we have it scanned, what do we do with it? And how do we lay out optional facility designs or factory designs and layouts? And then we're going to continue to build upon that model. And part 3 will be about validating that model that we create in the layout session and go through some simulation technology. And using that with the Autodesk tools, and then talk about the ownership, the pre-construction, construction management, and closeout of the installation of that new equipment line, and then finally close out with maintaining the facilities and maintaining that as-built model and leveraging that data through facilities management and operations. So with that, we finished in 42 minutes. So right on, a little bit over schedule, Lori, but pretty close. So thanks everybody for your time today. We value your partnership at IMAGINiT and look forward to working with you.